Thank you very much for inviting me. So I'd like to talk about bringing data together, but in the context of this thing called the National Digital Twin. And so I feel that I need to provide a fair bit of context as to what on earth that is and why we need it. But then eventually get round to the Gemini principles, probably on my very last slide. So we're defining this national digital twin as an ecosystem of connected digital twins. And the whole point of it is to enable better decisions faster across the whole built environment. So that might sound like a bit of gobbledygook. And so I feel that I probably need to kind of take a little bit of a step back, explain what we mean by infrastructure, what we mean by digital twins, how they're connected, and where data comes into all of this. So let's jump into that context. And the first thing is to say that this is all following some really quite nicely aligned government messages. So going back to the industrial strategy, which talked about the importance of having some kind of information management framework, is beginning to recognize the importance of information and not just the physical assets. So that's a really good thing. Then we had this transforming infrastructure performance report. And I think that was really important because what that did was point to the importance of existing infrastructure, not just the new stuff that we keep on building. And I'll come back to why that's so important. And then the really key kind of big daddy of the reports that is driving all of this is something called Data for the Public Good, which came out about 2 years ago. And can I just have a very brief show of hands to see who's come across Data for the Public Good? There's a few of you. Good. For those of you who are not familiar with it, I think this is a seminal paper, a seminal report. And it looks forward maybe 30 years. It has a number of quite high-level visionary recommendations, top of which, to my mind, is this recommendation that we should move towards having a national digital twin. And the whole point of that is to facilitate better outcomes for the ultimate customer, which is you and me, the taxpayer. But in order to facilitate that, they recognize that we need to put in place some kind of information management framework. And really what that's to do is to enable secure and resilient data sharing across the built environment. Again, I'll come back to that. And then in order to facilitate that, they recommended that we should bring together people from across government and industry and academia so that instead of everyone working in their own silos, doing all sorts of very clever stuff, that we should actually come together, agree a direction to go in, and then help the whole industry to go in that direction. So this Digital Framework Task Group has now been formed. It was recommended by the National Infrastructure Commission. It was approved by Treasury. It's now been working for just over a year and has made, I think, some pretty good progress in that time, but there's an awful lot further to go. So the Digital Framework Task Group is part of the Centre for Digital Built Britain. And I find it difficult to say that, so it's much easier for me just to say CDBB. That's been established at Cambridge University. And CDBB are the guardians, kind of curators, the owners and protectors of our national vision, this vision for a digital built Britain. And we have, I think, already laid a pretty good foundation for this. Something in the built environment called BIM that a number of you may have come across. It's building information modeling. It's set a very good foundation for us because what that's done is indicate just how important information is in the delivery of new assets. And improving information management through the delivery process, recognizing that if we lose information, we lose value. All of that has set a foundation on which we can build. But it really is just a beginning, because we can imagine going well beyond that, not just seeing the value of information through the delivery process, but also on into the use and the operation and the maintenance of our infrastructure assets. And that's a really good thing. And that's where digital twins come in. I'll explain those in a bit more detail later. But then we can imagine going beyond that again, getting into this area of integration, which is where we can start to see information shared across organizational boundaries, shared across sector boundaries, facilitating connections between our different infrastructure sectors to unlock even more value. And so you can see that there's some kind of progression there, and Digital Built Britain can be explained in those terms of design, build, operate, and integrate. And if we're being very simplistic about it, you can kind of see that the operate bit is about deploying digital twins, and then you can see that the integrate bit is about connecting those digital twins together. So I will come back to explain what I mean by digital twin in a moment, but let me first talk about the infrastructure itself. What is it that we're talking about? What is this scope of the built environment? And a lot of it will be very familiar to us. So I guess all of us will have used some form of transport to get here today. And if we look at transport, we can see that it's an amazing, interconnected, complex system. Even if we just look at the rail system, that would be true. But then if we look at road as well and air transportation, you can see that it is a complex, interconnected system. And that's just the tip of the iceberg, because what we also can see is a complex, interconnected system in energy. And this is likely to become more complex and more interconnected, particularly as we move towards having prosumers and distributed networks, etc. And so the idea of energy being a separate system makes no sense, because we all understand how energy plugs into everything else. So it's plugged into transport, plugged into water as well. This is a complex, interconnected system, something that we don't often pay much attention to because we just turn the tap and out comes the water. But behind the scenes, this is an amazing machine that we've built to provide us with clean water and take the dirty water away and then cause no harm to the environment. So water, another complex, interconnected system. Telecoms is one of those spine systems that, again, like energy, is connected into everything. So we can see that you've got transport provided with energy, but then energy connected into telecoms, facilitating that. These are connected, interconnected systems. And maybe sometimes it comes across as the poor relation of economic infrastructure waste, but it shouldn't be. And certainly as we move towards having a circular economy, we might want to change the name of it, not call it waste anymore, but see that everything is a resource, nothing is waste. And so you can see that this sector, this economic infrastructure sector, which again is complex and interconnected, will become more complex and interconnected as we have the circularity and resources coming back into the system. So that's economic infrastructure. And you can see how I've kept on saying it's complex and it's interconnected and it's a system. But that's not the whole story, because we also have social infrastructure. And so that would be hospitals and prisons and schools. And then obviously we live somewhere, so we have residential, commercial, industrial buildings, all of which are served by that economic infrastructure that I talked about before. And that's not to mention another complex, interconnected system, which is our natural environment. And all of those things I've talked about so far, the social, the economic infrastructure, sits in a place. It sits somewhere interfacing with the natural environment. So what I've built up, what I hope I've built up, is this picture of the built environment being an amazing, complex, interconnected machine that we have built. And something which I think is amazing is that because we've been building it slowly over a period of time, it's a little bit like that frog boiling, that we haven't noticed what we've built. But what we've built is the most complex machine that humans have ever built. And it's kind of effectively part of Spaceship Earth, and we're flying this spaceship. This is a machine that enables society to work. This is absolutely fundamental to our way of life. And we can see that this built environment that we've built around us is a platform for human flourishing. And if we want humans to flourish more, then we need to be tweaking our built environment to facilitate that human flourishing. So this is an essential thing. I think quite often we don't look at it, and this is the reason why I'm spending so long kind of hammering this point, because it feels like we've built a machine, but we don't really look at it as a system of systems. We don't manage it that way. So I think that there are a number of systems-based views that we should take on board around our built environment. The first one that I've laboured quite a bit, it is a system of systems, and therefore we should manage it as such. We should have a strategy for the whole system of systems and manage it that way. We should pay attention to what we've built in order to facilitate human flourishing, which is the second point. We can see it as a system of services because maybe the language of mobility as a service is becoming a bit more familiar. But really, we don't want infrastructure for itself. We want it for the services that it provides to us. And so we need to understand our infrastructure in relation to the services it provides. And so understanding performance of infrastructure needs not just to be about understanding its performance as a system, but understanding its performance as a service as well. And that's really important because you can imagine that if we cranked up the performance of infrastructure as a system, and maybe we get loads of people through the transport system, but it feels horrible, that wouldn't be the right answer for society. So we really need to understand our infrastructure in relation to the services it provides and what it feels like to use it. Then we've got the cyber-physical system, which is really about applying Industry 4.0 thinking to infrastructure. It's recognizing the value of digital assets because we're actually very good at managing our physical assets. And in this country, we've developed all sorts of methodologies and asset management. We get a lot out of our physical infrastructure, and we're pretty good at managing it. What we haven't yet done is recognize the value of the digital assets, which have genuine value, and if we were to genuinely value them, then we would manage them better. And so bringing the digital and physical together starts to unlock more value, just the same as Industry 4.0 thinking has already done in manufacturing. And then the final point about seeing it as a sustainable system, this is not just the sustainability from the point of view of driving towards net zero, which is big enough in itself, but it's also seeing the importance of resilience in the system, the importance of security in the system, to have a genuinely sustainable system. And really the underlying argument about this is that we must sustain this infrastructure. It must be sustained, and therefore it's incompatible for it not to be sustainable. Because basically, as long as we want society to last, then this infrastructure has to last too. Kind of one more point on that is that we see asset life cycles for individual assets, but the system of systems doesn't have a life cycle. It has to go on forever. And so when we've got to become pretty good at managing assets through their life cycles, there are some things which we need to do about being able to manage a system that has to last forever and manage the resources in the system. I already talked about waste having to change. If we're moving towards more of a circular economy, then potentially what we need to do is manage resources through multiple life cycles. And so what we need is a competent tool set to do all of these things. If we've suddenly now looked at infrastructure as this amazing machine, how on earth are we going to manage it? So one part of that, I think, is to really understand this value of information, which you need not to be told about at all. But to a certain extent, the infrastructure industry does, because our data currently is not in a great state. You see data in silos, you see data not being valued or managed properly. So there's an awful lot that we have to do just in some basic data management to get our data fit for use. But even once we've got our data fit for use, there's an awful lot that we have to be doing in order to make sense of it, to add value to it, to generate insight, to enable better decisions. And I think that this information value chain is quite useful for showing that there is a genuine value chain. It shows where various bits of technology fit in, and so we can see the place for IoT, we can see where AI fits, rather than those just being shiny bits of technology. When they're fitted into this framework of an information value chain, suddenly they have purpose. And the purpose is that big picture of infrastructure providing a platform for human flourishing. And the reason for saying that, really, is that if we don't look at the ultimate purpose of benefiting people, then there's a potential that we just get into kind of geekdom and playing nice games with data. But the thing is that it's got a real ultimate purpose of facilitating this greater human flourishing. And what we see as being the core thing that unlocks that value are these better decisions. That seems to be at the fulcrum. And so what we see in this value chain, starting with data, going to insights, to decisions, leading to better interventions, leading to better outcomes. And so we have a direct connection between data and outcomes. That feels important. So eventually, I can come round to introducing the digital twin. So digital twin, put simply, is just a digital representation of something physical. And in the built environment, what that means is a digital representation of assets and processes and systems in the built environment. And you could say, well, what about any other model? I mean, we've had models for yonks, and that's true. What makes a digital twin, though, is the connection to the physical. And so you can see data coming from the physical environment, being processed within the digital twin, generating insights to facilitate better decisions that enable better interventions back in the physical world. And so what you can see here is embodied that concept of the information value chain. And what we see is that digital twins are kind of having some kind of massive growth at the moment. Everyone's getting very keen about them. I think it's important that we kind of keep our heads on and make sure that they deliver genuine value rather than just allowing it to kind of shoot up the hype curve. However, there is genuine value in digital twins used properly. And we know that's the case because we can look at other industries where digital twins have been used incredibly well, most particularly manufacturing. But there are other examples of digital twins which we might be familiar with, like, for example, in Formula One, where live data streams from the cars, decisions are made right there and then, based around a digital twin, feeding into almost instantaneous interventions. So digital twins are not new to humanity. They might be quite new to infrastructure. So we can see that digital twins can unlock value by facilitating these better decisions. And that would be a great thing on its own. But if we've bought into the idea that digital twins themselves can be of value, why wouldn't we start to think about how they could be connected up? Because if you've got a digital twin of a train and you're helping to drive better operational decisions around that particular train, you've also got a digital twin of the signaling system and of the track. Wouldn't there be some data that is relevant from one to the other? And so the idea really is to be sharing the relevant data from one twin to another. And if that makes sense in the context of a rail network, then it also makes sense to be sharing data across digital twins of different parts of the transport network. And this can then look very much like an integrated transport network. And wouldn't it be wonderful to genuinely have one of those? And if it makes sense to be doing it across a whole sector, like transport, why wouldn't we then think about doing the same thing across sectors, across transport and energy and water? Because as I illustrated before, in the physical world, these are all connected up. And so in the digital world, there's something analogous that says we should really be considering how to connect up the digital twins across different sectors. And this is not just a kind of a theoretical thing, because where this really makes sense is where all of these sectors come together. And where that quintessentially happens is in the context of a city. In a city, these sectors of different parts of economic infrastructure come together in the service of people. And so it's in the context of a city where it really makes most sense to have digital twins that can talk to each other. But then we have other examples which are almost like mini-cities. An airport is like a mini-city. So you can see that in the context of place, it makes sense to bring digital twins together in this kind of way. And so I've kind of done a bit of arm waving really over the definition of digital twins, and potentially it would be useful to understand a little bit about where the benefits would come. So an example at an operational level is that you could use a digital twin to help facilitate better operational decisions and optimize the performance of individual assets. At a network level, you could be using a digital twin of the network to facilitate better decisions about the resilience of that network. And maybe at a sector level, you could be using a digital twin to help facilitate better planning decisions and better investment at that sector level. So what we anticipate is that there would be many different digital twins coming in different shapes and sizes. And we're not saying that it has to be this size or that size. They're all fine. They're all digital twins. What we do see is that there's real value in connecting them. And how do you connect them? It's all about shared data. It's about sharing data across organizational and sector boundaries. And the real challenge that we have in the National Digital Twin Programme is working out that core problem of secure and resilient data sharing. And what that then does, I guess, just to loop back to my rather long introduction to infrastructure itself, is describe a tool set that is competent for the kind of infrastructure that we have. This complex interconnected system, we have the potential, not just in digital twins, but in connected digital twins, to have the tools at hand to enable us to answer some very complex systems questions. And so, for example, with net zero, that's something that can't be done just in isolation. There's going to be some complex trade-offs between sectors required for that, so you need a tool that is competent to do it. And at the heart of all this, because there is a danger that it sounds like an almighty great big problem, but in describing it as an ecosystem of connected twins, the cell from which that ecosystem is grown is really just a connectable digital twin. So a digital twin by itself is great, but if we can connect them up, then we can grow this ecosystem. And in fact, if we only connected 2 twins up, that's the beginning of the ecosystem. And what we imagine is that it might be a 30-year, certainly multi-decade, multi-generational journey to get to the national digital twin of this kind of connected up ecosystem. But the thing is, we can unlock some value now as soon as we start delivering the initial digital twins and the initial connections. So it might be a 30-year journey, but we should be looking for real value in the next couple of years. And the kind of value should be unlocked in many different ways in terms of benefits to society, which I'd like to run through, but I'm sensitive to time. Benefits to the overall economy. I think this one's an interesting one, because if we look at the connection between infrastructure performance and the major economic metrics, we can imagine that if we can improve that performance, there would be an improvement in the major economic metrics, things like GDP growth and productivity, etc. But at the moment, we don't know how to measure performance of infrastructure. There is no such measure. And so you can see with digital twins and connected digital twins, there's a route into understanding exactly that. And how wonderful would it be to be able to turn up the dial on infrastructure performance in order to turn up the dial on the major national economic metrics. Benefits to business, because what we see here is potentially the opening up of a whole new market. Because infrastructure, maybe for the last 200 years, has been dominated by construction. It's all been about building new stuff. And that's really important, and it will continue to be important, because the construction sector is worth something like 8% of GDP. So I'm not denigrating that. I'm just saying that there's a whole new market here in the value that we can unlock by using our information better across the whole of the built environment. And so what we want to do is actively create that market, have a low barrier to entry, make sure that there's lots of players can come in and offer that value. And then benefits to the environment. I've already talked about net zero. I've already talked a bit about moving towards that circular economy and having a means to manage resources through multiple life cycles. So many different benefits at a high level. And if we buy into all of that and we think, yes, that's great, let's do that. Okay, go for it. We need to work out how. How on earth are we going to do this? It sounds a little bit complicated. So I'd like to spend just a little bit of time talking about the how of making some progress on this. And in particular, it's the how of sorting out this issue of secure and resilient data sharing across organizational boundaries, because that's the problem we have to solve. If we solve that, then the rest almost comes for free. How do we do it? So I think there's 2 really big ways of getting it wrong at 2 ends of a spectrum. So at one end of the spectrum, what we could do is lock some experts in a room. It might even be you. We could lock you in a room and say, what's the perfect answer? How would we solve this problem for infrastructure? And then we could impose that on the industry. Now, unfortunately, that wouldn't work, mainly because we're British, but firstly, we wouldn't come up with a right answer, not just in isolation in a room. We'd probably take too long about it, and while we were taking the time doing that, somebody would have gone on and done something else. And then, crucially, when we came to impose it on the industry wouldn't have it. So a top-down authoritarian approach, no matter how expert it would be, would not work. The other end of the spectrum, another way that I think wouldn't work, is to be fully Darwinian about it and go fully bottom-up, which incidentally is the default option. If we do nothing here, then everyone will do their own thing. They'll probably get very keen about developing digital twins. They won't talk to each other. They'll all set up their own data models, their own information architectures, and then when we come to try and share data across them, we'll say, oh, this doesn't work because the data's all inconsistent. And so the bottom-up approach is unlikely to work. It would take a long time, and even if there were some dominant solutions appearing in the market, they wouldn't necessarily be the right answers. So bottom-up doesn't work. However, there's something in each of those that is attractive. It is attractive to have experts who know what they're talking about, who can see the bigger picture, and who can kind of tussle with these big issues. It's also really good to have practitioners who learn by doing, and we can capture that best practice. So the approach that we're trying to take in CDBB is to bring both of these things together. And rather than have one or the other, it's kind of somewhere in the middle, and do both. And so we've formed something called the DT Hub. This is the Digital Twin Hub. The idea of it is that it should be a collaborative learning community where people who are actually in the practice of developing digital twins can come and share their lessons, share about the holes that they've fallen down. And we have just announced that the British Standards Institute has been appointed to help facilitate that hub, because we feel it needs some energy put into it. Firstly, to coordinate the community, but then also to curate the content that comes from the community. And the idea of that DT Hub is that they would learn by doing and they'd progress by sharing. And so we'd capture the best practice that we identify and turn it into, firstly, guidance. If that guidance works, maybe turn it into standards. And then also we'd want to grow case studies. So where people are successful, we'd capture it so that others who are going to follow on can use the previous people's case studies to feed into their business cases and convince their boards. So the DT Hub is kind of a forge for standards and case studies. But then we're also establishing this thing called the Commons. And the idea of the Commons is kind of where some experts sit. And we're trying to identify the minimum we would need at a national level as kind of common shared rules that would unlock consistency of data across the rest of the industry so that this secure, resilient data sharing can happen. And we're specifically aiming for the minimum possible, because it would be possible to imagine everything that could possibly be helpful and stick it in the Commons, and we'd be here forever building that thing. And so what we're doing is trying to identify the absolute minimum that would be needed. And at the moment, what that's pointing towards, it's early days, but what it's pointing towards is some kind of upper ontology. We're calling it a foundation data model. The idea of that is to facilitate consistent data modeling across the built environment. There's something about a reference data library. And what we're seeing there is it probably would be some kind of distributed, federated reference data library, so that those who know best about reference data are the ones that control that reference data. So we have an authoritative source, but that it can be pulled together into an overall national reference data library via federation. And the idea of that would be to facilitate a consistent approach to reference data management. And then the third thing that we think we will be needing is some kind of integration architecture, which is kind of more of the plumbing to enable this to actually work, the sharing between different organizations. But we think with just three things, which definitely need to be challenged and developed, then the vast kind of quantity of different organizations within the built environment can then go away and do their thing. So we're not trying to control them, we're just trying to facilitate alignment. So that's the Commons and the DT Hub, and that effectively sits at the core of our work, and it's the forge, we think, from which the value will be derived. But in order to feed into that, we need to do quite a bit of work on the overall approach. That work stream is nearly done. We need to do a lot of work on the governance, not just to work out the governance of how we put this in the first place and roll it out, but also the ongoing governance of data sharing across organisations in the built environment. And then we see a couple of enabling streams. One is specifically to go and find whatever could potentially block us and then address those things. And those could be commercial blockers or regulatory or legislative blockers. We don't think technical blockers is going to be a big thing. We think that technically this is easy. We think that the bigger issues are likely to be human. And then the change piece, which is all about helping to enable this to be rolled out across the built environment. So we're specifically looking at what incentives are needed to get people to go down this road. And obviously it's preferable if market forces drive it rather than a big stick of legislation. And so we're investigating what would it be that would incentivize each part of the built environment to make that move in the right direction. And driving all of this, or guiding all of this, I said I'd eventually come around to it, so now you know that this is the last slide, are the Gemini principles, which is really where we started. So a year ago we published these, and the idea of this was to put out there a seed crystal to engage the wider community in a discussion about the values that should guide us on this journey. Because we see that if we're going to have a national digital twin, ecosystem of connected twins, that it has to be good. What was driving it originally was this report, Data for the Public Good. So the clue's in the name. If we're going to try and make it genuinely for the public good over a long period of time, we feel that it needs to be driven and guided by values. Because we can see that technology will change very rapidly over 30 years, but values are probably something that are likely to be more persistent. So let's talk about those values. We can change the values on the journey if we want, but let's talk about it up front so that we are values driven. And you can see here they come under the three headings of purpose, trust and function. And trust, I think, is one of the really interesting ones in the middle, and what constitutes trust. And we saw that there's a balance between both security and openness. In that case, we're not saying what that balance point is. We're saying it's important that it should be secure, otherwise it won't be trustworthy. It's important that it should be as open as possible, otherwise it won't be trustworthy. Where's the balance point between those? That should be a dialogue within society. And then there was also the quality point, which is good that that's come out earlier on. What we feel about quality is that the National Digital Twin should be built on data of appropriate quality, but the quality should relate to the purpose to which it's put. We don't think that you can just say it's high quality or low quality. It depends on the purpose to which the data is put. I'd quite like to talk about all the other principles in here, but what I feel might be better is to draw a line under it there and see if I've spurred any interest or any questions. I don't guarantee that I could answer them, and particularly not from people who know their data, but I'd be really interested to kind of get some feedback and explore how we might engage on this. So, any questions?
I'm a very enthusiastic participant on the periphery of some of this development, and one of the reasons is because all our businesses are connected to the built environment, so we need to get aware of what they're doing just so that we can connect consistently. But I also think we've got potentially things to teach them, because you can easily argue that a customer database is another version of a digital twin. It's a collection of examples of physical behavior, the physical behavior of consumers. It's collected together digitally, and then it's used to make decisions, which then hopefully impact those consumers. So we already have those loops, and hopefully if we can make those interchangeable using some of these principles, that's a really useful and hopefully development process. So my first question was that earlier on you said you wanted to have a bit of time to talk about the benefits to society, which you've got a little bit of time to sort of expand on that, shall we say?
Yeah, I think that the root of the benefits is in these better decisions. Being able to make better decisions faster and cheaper can lead to the better interventions. And those better interventions could be better operational interventions or better maintenance interventions, better investment interventions. And so I see where society benefits is that they basically get more out of their infrastructure per whole life pound and get better outcomes, economic, social, and environmental outcomes. And we could dig into kind of some specifics of what that would look like, but certainly when it comes to making transport genuinely more integrated, so that what matters is getting from one place to another rather than what time a particular train is. That's the kind of thing that I think people would want to move towards, is if anything, is seeing infrastructure even less because it's just made for them rather than they have to fit with whatever has been provided. And so I think having a much more people-centric infrastructure is a key part of where society benefits. But picking up on one of the earlier themes about not leaving anyone behind, then we can specifically work with kind of target audiences to ensure that they're not left behind, and that's a benefit to society too.
Yeah, we had a good example of the interconnectedness when we had those 2 power stations drop out a few months ago, and that caused all the trains to stop and then not be fixed because the new trains couldn't be re-switched on or something, couldn't they? Sorry, are there any other questions? I could, David, over in the back.
Hi, Mark. I just wondered, within digital twins, are they just reading data from the internal performance of the infrastructure? So, for example, in the transport realm, where something like leaf drop obviously has a big impact, that would be an external data set. When would that get fed in?
Yes, very much so. So the idea would be to bring in data from whichever sources are relevant. And so with that leaf drop issue, you can imagine that the weather forecast for the night before would be really relevant, because it's not just that there is a leaf on the line, but that there's going to be a leaf on the line. And so the answer to your question is a definite yes. And we see that the internal data, if you call it that, relating to the assets, what they are and where they are, and their performance and their condition, all of that is really important data. But then there's an awful lot of data that comes from outside. So, for example, geospatial data, which kind of underpins all of this, because everything happens somewhere. But then you can also see that in many cases, and I already used the example of weather data, that affects most of infrastructure too. So we need to be seeing the interconnection between data, and that's a very large part of what this connected digital twins is intended to do.
Question at the back.
It is. You mentioned all of the networks of infrastructure. I was just interested you didn't mention people, because obviously people are the people who use the infrastructure, and all of those organisations have vast quantities of customer data. So is there I can imagine the benefit of having a digital twin for the citizen as well.
Yes. I mean, it is a very good question, and I think that as a society we should address that. It's not part of the national digital twin because it's looking, as I described it, it's very much looking at the infrastructure that serves the people. So I hope I got it across that the whole point of doing all of this is for people. It's not like people are being forgotten. That's the point of it. It's for people. But what we're not trying to do is model individuals or come up with a digital twin of each person. I think that would be a really good conversation to be had more broadly. It's not the scope of the National Digital Twin, but somebody's going to have to ask that, because if digital twins have this kind of value that I've explained for infrastructure, you can imagine that having a digital twin for yourself could be really useful, particularly when it comes to kind of medical outcomes and whether you should be doing more exercise or whatever. So I have a feeling that it's a debate that should be had, and it's just outside of our scope.
Meteorological forecasting is, in essence, a digital twin of the global
Very much so. Very much so. And what I would hope is that as we go on this journey, we're going to see that there's lots of lessons from lots of different places that we can bring together. And there'll be some surprising learnings from surprising places. And I think when it comes to looking at an actual digital twin and kind of breaking into the inside of it, there's something about it which is about data, just handling the raw data, getting it in, doing something with it. There is something about the model code, and then there's something about the visualization to help humans to see what has happened within the digital twin. Now, I think I'm oversimplifying things, but each of those three areas are big areas in themselves, all of which deserve sharing of best practice and knowledge across the piece. But I think that there's some amazing work being done on data visualization, so we should be able to learn those lessons, as well as what I think you're pointing to, which is in the model code and how you actually go about the simulations.
Yeah, and the presentation and interpretation of error.
Yes, absolutely. Absolutely, but what I think we can see is that the potential for sharing that and unlocking the value of the sharing is enormous, but we need to kind of put in place the infrastructure to enable it to happen. And what we're hoping is that the DT Hub will be part of that. It won't be all of it, but if we as a society and as an industry get our heads around this big joint program, then we've got an impetus to learn from others.
I'll take one more question, because I know as chair, it was going to be the one at the back with Pete, but because I sort of know that as chair, when it comes to reminding you to fill out your feedback forms at the end, the most important thing is not delaying coffee or lunch. And I'm in danger of delaying coffee. So if all the other ones can be addressed to Matt after we've finished. Pete,
Thanks,
if you can.
Pete Benton from the Office for National Statistics. I think you talked about the need to incentivise somehow people to want to do it. And when I look at the plethora of people playing in this same space, it's an issue that we've got digital triplets and sextuplets. There are records about the same thing in many different places. And you look at the addressing infrastructure and how many years it's taken to get the different organisations to come together and have a common set of data. How do you see your way through that challenge of the number of players in the space wanting to pull this stuff together?
Yeah, it's a great question. And I think that in the early days of this journey, it's likely to feel quite chaotic, and there's going to be different people kind of doing slightly similar things in different places. But as per the previous question, we can learn by sharing and identifying what is best, and hopefully having a kind of a consistent shared vision, which CDB are trying to put out there. Then we can have alignment that means that these different ways of doing things can come together. So I think there's part of the answer to your question is about knowing where we're trying to get, so that we can take the steps that are aligned to get there. So that's part of it for me. Another part of it is just to do with what incentivizes people to do the right thing. And I think that you can see that also as one of these spectrums. At one end of the scale, you've got, just because it's the right thing to do, and there might be some kind of reputational benefit of doing the right thing. But then there's kind of market forces and self-interest. You get more money if you do the right thing. And at the other end of that spectrum, you've got the big stick of legislation, and you have to do it, otherwise you go to prison type of thing. And I think that what we should use is the full spectrum of incentivization appropriately, but starting on this side and only going that side if we absolutely have to. Thankfully, the ONS sits on the Digital Framework Task Group, and so kind of your thoughts can feed into that. But one of the things that I was saying earlier on about the connection between the performance of infrastructure and big national metrics, I think if we establish that clearly, that itself will be a massive incentive to infrastructure to get its act together and to do what I was talking about. And another one, and I know the coffee thing, so just one more thing. I think as soon as we start genuinely putting a value on data sets, and do it in a robust enough way that it gets on balance sheets, that will probably be the biggest incentive for everyone to sort out their data, because suddenly accountants and people who sit in boardrooms will care about data. And we might have cared about data for decades, but unless the boardroom does, nothing much happens. So I think that is the essential thing, is get data sets evaluated, get the value of data onto balance sheets, and then suddenly it will all go.
Cool. As I say, I must thank Joel and Mark now for getting us off with this first session, contrasting the high-level conceptual stuff from Mark and the work on the ground delivering results and from data from Joel. So thank you both very much. And please enjoy some coffee.